Chapter 5. Scripting. Languages. There's three: JavaScript, Boo, and C#. What Unity calls JavaScript is actually a misnomer and should be referred to as Unity script. The two share some syntax, but the foundation is very different, so your JavaScript books are going to confuse you more than inform. Some start off with Unity script thinking that it's easier due to C# being somewhat more verbose, but there is no free lunch and those shortcuts can cost you dearly, wasting days finding bugs or worse, shipping buggy products. Which is the best to use in Unity? I won't even say it depends because C# is better structured, runs faster, and less error prone than Unity script. If you're a Python guru, perhaps you might want to use its distant cousin Boo, but C# has a lot of features and advantages that neither Boo or Unity script can compensate for. Most of the syntax for Unity's API, or a collection of code that can be used without knowing its mechanics, is very similar to all three languages and can be found in the scripting reference. Our first script. Let's create a C# script that will let us do something simple. Move a box around a simple level. We're going to give this box a special component called a rigid body, which will allow its collider to interact with other colliders through a physics engine. To begin, create a new folder called Scripts, Code, or something descriptive. In the project panel, choose C# and give it a name, such as Box Mover. You should name your scripts with a capital letter. Now, as I said before, Unity does not actually handle the source code editing. You can use other IDEs, such as Sublime Text, for example, but most people prefer the app that comes with Unity, MonoDevelop. When you double-click on your script in Unity, you should see the program open. If you plan on coding and don't want to burn out your eye's photoreceptors, you can change the color scheme by going to the Preferences, Text Editor, Behavior, and then choose Syntax Highlighting. I personally think Oblivion is quite nice. So here we are at our first script. The top line indicates that we're using Unity's API, or a collection of scripts that we need to run Unity-specific tasks. You will not always need to list this. For example, if our script adds 2 and 2, we don't need anything from Unity. A using statement is just a shortcut to access those scripts. The other namespace is from Microsoft, which is developed in C# and it allows you to use features such as coroutines, which is a special and very useful type of function. You will see the name of the class is the same as the file that you created. If you do change the file name, make sure it changes on the class name as well. Otherwise, you will be unable to attach the script to your game object. The mono behavior bit implies inheritance, which means that the class you created is using data from Unity's built-in class. In C#, a function is called a method, and there are two methods that can come with the default template: start and update. Within the start method, you can put in any code you want to execute before the gameplay begins. The update method will run all the code you put inside for every frame such as player input, movement, and any other actions you want to handle during gameplay. If you're a C# veteran, please note that the construction of objects happens in the editor. To move our box around, we will need to assign it a walk speed variable and a strafe speed variable or movement to the side. There are two types of ways we can indicate a number in C#. The first one is int, short for integer. An integer is any whole number, including negative numbers at 0. The second type is float, short for floating point, which is a rational number, meaning that it can be an integer float with a decimal. The best type to use with things like speed or floats. If we don't need to perform any operations with our variables before gameplay, we do not put them inside either of our methods. To have our variables accessible outside of the script, we need to make them public. This way, we can change these values inside the Unity editor and do not have to edit the scripts each time. To see this in action, let's use a command that displays a message, debug.log. I want to see this value appear every frame, so let's put it in the update method. Now let's go back to Unity to see if all of our code has compiled correctly. If we look at our console window, which can be accessible through Window Console, we will see no errors pop up, meaning that the compiler does not detect any problems with the script. If you have decided to use Unity script, keep in mind that you might see the problems during runtime even if you do not see any now. That's the advantage of using C#, being able to weed out problems before the game is compiled. To have our script do something, it needs to be attached to a game object as a component. We can do so by simply dragging it onto our cube. We can test our game by clicking the play button, or by pressing Ctrl or Command P, depending on your OS. The cool thing about Unity's play mode is that you can change things on the fly. This way, you can tweak a lot of parameters as the game is played. An important thing to keep in mind is that once you've exited play mode, all of your changes will be lost. To move our box, we need to assign some sort of input. If you're developing for desktop, you may use Unity's Input Manager in Edit, Project Settings, Input, where you can configure keyboard, joystick, and gamepad controls. We see that the horizontal and vertical input axes are already mapped to the W, A, S, and D and the arrow keys. The user will have access to change those if they prefer, so let's just let them be. We won't be using the other controls, but you can also map three types of fire controls: the delta or position change of mouse movement, and the movement of the window in the X and Y coordinates. This all seems fine, so I'm going to go and add the input in our script.